Hello students, in this video I am going to explain what is pseudocode and what is the pseudocode for expressing algorithms. In the last video I covered what is an algorithm, what are the properties of an algorithm. I will provide the link for the previous videos in the description box. If any want to see, you can check that. So today we will start the video. What is pseudocode? So pseudocode is an informal and artificial language that helps programmers to develop an algorithm. So pseudocode is an informal nothing but user friendly. Artificial language nothing but human language. So it is an informal and artificial language that helps programmers to develop an algorithm. So if you want to write an algorithm, you have to use the pseudocode. Now we will see pseudocode for expressing algorithm. If you want to write the algorithm, you have to know some basic rules. So what are the rules? Let's see. All comments must begin with double slash and it will be continue until end of the line. So you can use this double slash for comments and that line. So once you use the double slash for any line, the entire line will be treated as the comment. For example, this is a comment. This is a comment. So once if any line starts with double slash, this entire line will be treated as a comment. That is the meaning of the statement. All comments must begin with double slash and continue until end of the line. So this entire line will be treated as comment. Next, blocks are indicated with matching braces, that is flower curly braces. This is the starting curly brace and this is the ending curly brace. So generally blocks can be used for compound statements. So compound statement nothing but the collection of simple statements, nothing but compound statements. So if you are having any compound statements in your algorithm, that you can indicate it with using curly braces. Except in Python, almost in all other languages, we use curly brace to indicate compound statements, right? So next third point, data type declaration is same as like int, float, char, like that. So if you want to declare any data type, how you declare data types in C, see here also, we will take same data types. Assignment of values to the variables is done using colon is equal to or reverse direction. So if you want to assign any value to the variable, you have to use either this one or this one. For example, A is equal to 10 or A reverse direction is equal to 10, both having similar meaning. Anyway, you can assign value to the variable. Okay. So there are two Boolean values, as you know, that is true and false. So when true and false will be produced whenever you use logical operators and relational operators. So at that time, these two values will be produced. Next, elements of multi-dimensional arrays are accessed using the square brackets. If you want to access any array element, you have to use square bracket. Logical structures of the pseudocode. So there are totally three logical structures. One is sequence logic, second one selection logic, third one iteration logic. First we will see one by one, and for each logic we will see the flowchart and related pseudocode. Okay. So first one, sequence logic. Sequence logic nothing but here instructions are performed in a sequence. One by one statement will be executed. That is what sequence logic. So statement 1, statement 2 are like that. Statement n. It has n number of statements. All statements are executed one by one. So what is the pseudocode for this flowchart is statement 1, statement 2 and so on statement n. So this is the pseudocode for this flowchart. The second one, selection logic. This is also called as decision logic. So we are having two selection logics, that is first one if then, second one if then else. First one if then. The flowchart of if is if the condition returns true, then sequence of statement will be executed. If the condition returns false, then the next statements will be executed. After the if, whatever the statements you have, that will be executed. What is the pseudocode? If condition, then sequence of statements, and if. If condition returns true, then sequence of statements will be executed. Finally, after that, The condition returns false and if. After if, whatever the statements you have, that will be executed. So, what is the pseudocode? If condition returns true, then the sequence of statements will be executed and end if. The condition returns false, after the if, whatever the statements you have, that will be executed. Next one, if then else. So the flowchart of if then else is condition. Condition returns true, then sequence of statements will be executed. The condition returns false, then false block statements will be executed. So what is the pseudocode for this flowchart? If condition returns true, then sequence of statements will be executed. Otherwise, if the condition returns false, then it will come to the else block and else block statements will be executed and it is the end if. The next logic is iteration logic. So there are three iteration logics we have. First one while, second one repeat until, third one for. So while nothing but it is the initialization step. So if the condition returns true, then sequence of statements will be executed and it will go to the again condition. We check the condition again. In case if the condition returns false, then control come out from that while loop. What is the pseudocode for this while loop? While condition returns true, do sequence of statements will be executed and while. So next one, repeat until. So repeat until flowchart is sequence of statements will be executed first. Next, it will check the condition. If the condition returns true, then again it will execute the sequence of statements and again it will check the condition. If the condition returns true, again it will execute the sequence of statements. In case if the condition returns false, then control come out from that while loop. So this will be work as actually do while. Do while nothing but what? First it will execute the sequence of statements and then it will check the condition, right? So at least one time the sequence of statements will be executed whether the condition returns true or false. So what is the pseudocode for this repeat until? Repeat sequence of statements until condition returns false. That is the pseudocode for this repeat until. The next one, for loop. This is the initialization. Next, it will check the condition. If condition returns true, then sequence of statements will be executed and then value will be incremented by 1 by default. Next, again, it will check the condition. The condition returns true, then again it will execute the sequence of statements, right? So this will be repeated until this condition returns false. Once condition returns false, then it will the control come out from that for loop. What is the pseudocode for this for loop? For variable is equal to variable. We have already seen how to initialize values to the variables, right? Variable is equal to value 1 to value 2, step 2 and sequence of statements. So for first here this is the initialization as well as the step is what? This is initialization step as well as this is the condition also. And to value 1 to value 2. So this you can see entire thing. Initialization and condition. This is initialization step and this is condition. Step, what is step? Nothing but this is the increment. So how many times by default, the step value is +1. If you don't provide any step, by default, the value will be incremented by 1. Otherwise, you can provide the step value +2, -1, +3 like that. Okay. So how it will work? Nothing but, for example, for I is equal to 1 to 5, do printf of high. For example, for I equal to 1 to 5, do printf of high. So here we want to print high as 5 times. So I is equal to 1 to 5. So how it will work? Nothing but I is equal to 1 and 1 to 5. Okay. So this is the initialization and this is the condition. And here we have not written any step, right? So by default it will take +1. I value will be incremented +1 for each and every iteration of this for loop. Okay. First it will take 1. Okay. So next, this is the condition 1 to 5. So 1 to 5, the condition returns true. So it will print high. Next, by default, the I value will be incremented by 1. That is 2. 2 to 5, the condition returns true. So again it will print high. Next, I value will be incremented by 1. Next, 3 to 5, the condition returns true, so it will print high. Next, I value will be incremented by 1, that is I value is 4. So 4 to 5, the condition returns true, so again it will print high. Next, 5, so it will include 5 also. So 5 to 5, the condition returns true, so it will again print high. Next, the I value will be incremented by 1, that is 6. 6 to 5, it will return false. Like this, the for loop will be executed. For variable is equal to value 1 to value 2, step do. So if you want to, for example, if you want to increment the value by 2 for each and every iteration, then you can mention step plus 2. Okay, at that time the value will be incremented by 2 for each and every iteration. So next one, the procedure or function starts with the word algorithm. Algorithm, name of the algorithm, and parameters list and pseudo code. You already know how to write the pseudo code using the logical structures and assignment statements, right? So using all these, you can write the pseudo code for any algorithm. Now we will see some examples on how to write an algorithm using the pseudo code. Write an algorithm to find maximum number in an array. So we have to find out the maximum number in an array. Okay. So if you want to write any algorithm, you have to take the word that is algorithm. That will be starts with any procedure will be starts with algorithm. And name of the algorithm, here I am taking the name of the algorithm as maximum. Can take any name, and here it is having array. Okay, because we have to take the array elements one by one and we have to check which one is maximum. We have to compare each and every element, right? So here A is what? Array name. So here I am finding the length of the array. Assume n is equal to a dot length. It will give the total number of elements of this array. So n contains total number of elements of this array. So we don't know what is the maximum element, right? So just assume max is equal to a of 0. So we are assuming the first element is the maximum element. I is equal to 1 to n minus 1 do if a of I greater than max, then max is equal to a of I. Finally, it has to return max. So this is the algorithm for finding maximum number in an array. So I will explain, don't worry about this algorithm. So first it will take array of elements, okay? So let us assume array contains the elements 2, 7, 1, 13, 5. So these are the array elements, okay? So this is the 0, 1, 2, 3, 4. These are the index positions of this array. So we don't know what is the maximum. So n is what here? Total number of elements. What is the total number of elements of this array? 1, 2, 3, 4, 5. So n has 5. Okay. So we don't know what is the maximum element. So actually what we will do, nothing but we are assuming 2 is the maximum element. Okay. That is a of 0. We are assuming the first index value is the maximum. Next, we are comparing this value with the next index position. If the max is less than the second element, next you have to update the max value. Otherwise, you don't need to update. If the max is less than the second element, then you have to update the max. Otherwise, you no need to update it. What you will do, nothing but what we are doing here, max is equal to a of 0, nothing but max contains 2. I is equal to 1 to n minus 1. So here 1 to how many? 5 minus 1, that it will take 1 to 4. We have to check the index position up to 4. Okay, I is equal to 1 to 4. Do if a of I nothing but what here 1. A of 1, what is a of 1? 7. What is the first case? If 7 greater than max. What is the max value? 2. If 7 greater than 2. Yes, condition return true. If the condition return true, then you have to update max value. So what is max value? Max is equal to a of I. I nothing but here what? 1. So a of 1. What is a of 1 value? 7. So max value. So now max contains 7. Okay. Again, by default, here step is plus 1. So I value will be incremented by 1. That is 2. Now 2 to 4. The condition returns true, right? So a of 2. A of 2 is greater than max. What is the max value right now? 7. So a of 2 is what? 1. 1 greater than 7. Condition false. So this will not be executed. Next, I value is incremented by 1. That is 3 right now. 3 to 4 condition returns true. Now a of 3. I is what? 3. So what is a of 3? 13. Is 13 greater than max? Max contains 7. Is 13 greater than 7? Yes. Condition returns true. If the condition returns true, you have to update the max value. Now max is a of 3. A of 3. Now what is the I value right now? 3. So max is equal to 13. Max is equal to 13. So next I value will be incremented by 1, that is 4. 4 to 4 condition returns true. So A of 4. A of 4 is what? 5. Is 5 greater than max 13? No. So this statement will not be executed. So what is the return max? Nothing but what is the max value right now? 13. So what is the maximum element of this array? 13. So this is how to find maximum number of this array. So like this, you can find out the minimum number of the array. Just you have to change the condition, and here you have to take minimum number. Minimum number is equal to a of 0, and I is equal to 1 to n minus 1. A of I less than minimum, then you have to update the minimum value. That is the algorithm to find minimum number. So now we will see the algorithm to find minimum number of an array. Find minimum number of an array. So what is the any procedure will starts with the word algorithm. Algorithm name here I am taking minimum. So it has one parameter, that is array. N is equal to a dot length. So this is the length of the array. Next, we are assuming minimum is equal to a of 0. For example, array contains 13, 5 to 21, 7. So we don't know what is the minimum element. So just we are assuming minimum element is a of 0. First element we are assuming it as minimum. Next, for I is equal to 1 to n minus 1, do if a of I less than minimum, then minimum equal to, in case the next element is less than the minimum element, then you have to update the minimum value with next element, that is a of 5. Return minimum. This is the algorithm to find out minimum number of an array. So what it will do first, we are considering, we are assuming a of 0 is the minimum number. So what is the minimum number right now? What is the value? It has 13. Next, we are taking So you no need to take the values from 0. We are having already the 0th value, right? So you have to compare values from 1. Okay. So if a of 5, what is the I value? 1. Here 1 to n minus 1, nothing but what? 4. So when I is equal to 1, okay, 1, the a of 1. What is a of 1? What is a of 1? That is 5. Is 5 less than minimum? Is 5 less than minimum? Condition true. If the condition true, then you have to update the minimum value. Now minimum value is a of 1. What is a of 1? 5. So minimum has 5. Next, here the default step value is plus 1. So I will be incremented by 1. Now I value is 2. So a of 2. What is a of 2? 2. What is a of 2? 2. 2 less than minimum. What is minimum? 5. So 2 less than minimum. Yes, condition true. So you have to update the minimum value. That is minimum is equal to now 2. Next, I value is incremented by 1. That is 3. So I is equal to 3. So what is a of 3? A of 3 is 21. A of 3 is 21. Is 21 less than minimum? What is minimum right now? What is the updated value? 2. Is 21 less than 2? No. So this statement will not be executed. Again, I will be incremented by 1. That is I is equal to 4. So a of 4, what is that? A of 4? 7. Is 7 less than, what is minimum? Minimum value? 2 only, right? Is 7 less than 2? No. Condition returns false. So this statement will not be executed. So next I value is incremented by 5. So is 5 to 5, is 5 to 4? Condition returns false. So it will return minimum. What is the last minimum variable value? 2. So it will return 2. So this is how to find minimum value in an array. So I'm stopping this video, students. So in the next video, we will see what is the space complexity and how to find space complexity for the algorithm.